Hey guys, this is the third video for chapter 10. Pretty short video just on the densities of gases. Now the density of a gas comes from the ideal gas law, much like most of everything else in this chapter. So let's take a look at what that looks like. For our ideal gas law, we have PV equals nRT, right? And we know from chapter 3 that moles multiplied by molar mass gives us mass, right? So if we multiply both sides by molar mass, denoted by this weird little m here, then moles multiplied by molar mass gives us little m, which is mass, right? So in this case, we have molar mass times PV equals mass times RT. Now density is mass over volume, right? So we need volume on both sides, or volume on this side, so we get rid of that. And we need RT on the other side, so we can have mass and volume on the same side. And so what we end up with is mass over volume is pressure times molar mass over RT. And mass over volume gives us density. Now that's a super important equation there. We can rearrange this to solve for anything we need to, but the most important one by far is molar mass, which will get density times molar mass times RT over P gives us molar mass. And that's super important because, again, we can take these measurements, right? We can find mass and volume, we can get temperature, and we can get pressure. And from those, we can get the molar mass of an unknown gas, something that we have no idea anything about. We can actually figure out the molar mass, the grams per mole. So let's take a look at what that looks like. Here we've got a molar mass of a gas has a density of 1.2 grams per liter at 279 Kelvin and 2.3 atmospheres. So like we said, molar mass is equal to density RT over P. So we have molar mass is equal to 1.2 R 0.8206, sorry about that, times temperature of 279 over pressure of 2.3. We can put this into our calculator and solve for our molar mass. When I do that, I get 12. 11.9 grams per mole. So that's a pretty easy one there. All right, let's continue on. Look at another one. What mass of hydrogen sulfide gas occupies a volume of 3.5 liters at 312 Kelvin and a pressure of 6.1 atmospheres? So we're asked what mass of hydrogen sulfide occupies a volume of 3.5 liters. Okay, this is just an ideal gas equation, but we can use the density equation to help us out here. Okay, if we wanted to. So we've got 312. So we've got PV equals nRT. We've got 6.1 atmospheres. 3.5 liters, I'll show you both ways. N, R, and T, 312. When I put this in our calculator, I get 0.834 moles, which has a mass of 28.4 grams. Now let's solve this with our density equation. So we said that mass over volume was pressure times molar mass over RT. Well, that also means that mass equals pressure times molar mass multiplied by volume over RT. We've got a pressure. We've got a molar mass, 34 in this case, H2S, gas. We've got a volume of 3.5 liters. We know R. And we've got a temperature of 312. And when I do that, I get 28.4 grams. So as you can see, they're equivalent. You can use all sorts of the tools at your disposal to solve these type of questions. You just have to know how to approach the problem. Anyway, that is the end of the video for the densities of gases.